Okay, so now we are looking at the homework questions that relate to naming and writing the formulas. So there are certain rules. So first of all, if you look at the periodic table, we discussed in the previous videos also, and in the lecture videos, that when we talk about the group numbers, these group numbers are associated with the valence electrons, and these valence electrons can be lost, or it depends on, depending upon the valence electrons, the electrons can also be gained. And as a result, we will have charges on these atoms. So all the elements that are in group number A, in group 1A have 2 valence electrons. So therefore, they will lose those 2 valence electrons. So they can look like they can have the noble gas configuration of the element that is 1 period above. So group 1A, 1 valence electrons plus 1 charge. Group 2A, 2 valence electrons plus 2 charge. Now let's look at group 3A. So group 3A is aluminum, but the other ones are also metals, but it can vary. But in technical, group 3A, 3 valence electrons and three positive charges. Okay. Now group 4A is a mixture. It is a mixture of non-metals. It is a mixture of metalloids and the metals. So here you see tin and lead. Tin and lead can lose 2 electrons and they can lose 4 electrons. So when they lose 2 electrons plus 2 charge, 4 electrons plus 4 charge. And so this is a variable valence state or variable oxidation state, or more than one type of positive charges. Okay. Next comes group 5A. Group 5A, 5 valence electrons. And in this case, we see nitrogen and phosphorus. These are non-metals. So they will gain electrons. So as a result, they will form -3 charge. Okay. Nitrogen becomes nitride. Phosphorus becomes phosphide with 3 negative charges. But we also have the metalloids, and we have a metal, bismuth. Now, metalloids are in between metals and non-metals, the characteristics, but the blue ones you see, bismuth is a metal. So bismuth has the capacity to lose 3 electrons, but bismuth can also lose 5 electrons. So as a result, bismuth will form +3 and +5 charges. Then we have group 6A. Group 6A is oxygen and sulfur, non-metals, and they will gain 2 electrons each. So they get 2 negative charges. Oxygen becomes oxide, sulfur becomes sulfide. Group 7A is fluorine. Fluorine, chlorine, bromine, iodine, all these halogens are very close to the noble gases in group 8A. So as a result, the group 7A, 7 valence electrons, but they will acquire only 1 electron, so they can have an octet. So the whole idea of group 5A, 6A, 7A to gain electron is to look like the nearest noble gas or have the electronic configuration that is like the nearest noble gas in the same period. Okay. So gaining electrons is energetically more feasible because it's just easily gain 1 electron, they get the octet. Okay. Now that's the deal with the non-metals. Now let's look at the transition elements, which are the D block elements present in the starting from 3D. Okay. So this is the 3B, 4B, 5B, 6B, 7B, 8B, and then you have 1B and 2B. Now, all this 3 to 12, all these. There are 10 columns. Out of these 10 columns, by default, all of them will have +2 charge. So that is just by default. But they also have the capacity to lose more than one type of charge, more than one electron, or more than one, they will form more than one type of positive charge. So for example, look at chromium. Chromium can form +2 and +3. Manganese, +2 and +3, but manganese can have more, +5, +7, +4. So manganese is very variable. Iron, +2 and +3, right? Cobalt, +2 and +3. Nickel, +2 and +3. So you see +2 is common in all. Copper, +1 and +2. Zinc is only +2. Zinc is not in a variable valence state. Silver also has +2. I don't know why they didn't write it here, but silver is +1 and +2. Cadmium +2. Gold +1 and +3, and mercury. Okay. So these are called a variable valence state. Now these are also present in your handout in a table. So we are going to look at the handout in the table later, but right now I have also listed them here, some of them. So here is this, the same story that we discussed. So just so you don't have to go back and forth, everything is right here. So you see that group 1A, 2A, 3A have 1, 2, and 3 valence electrons. So 1, 2, and 3 positive charge. And based on these positive charges, the bonds are formed. So group 1A will only form 1 bond. Group 2A forms 2 bonds. Group 3A forms 3 bonds. Okay. Now comes group 4A. Group 4A, as we said, is a mixture. So they can form bonds by the transfer of electrons or form by the sharing of electrons without any charges. Okay. So group 4A can have like +4 and -4 also. Group 5A, 6A, 7A, 8A, that's where the non-metals start. But at the same time, we're just looking here at the non-metal scenario. So -3, -2, and -1, these relate to the non-metals we discussed earlier. But based on these negative charges, again, -3 means 3 bonds, -2 means 2 bonds, -1 is 1 bond, okay? So that bonding, since this chapter is on bonding, it's very important you get that also. Now, we talked about the octet rule, 8 electrons in the last shell. And that octet makes the element or the atom have a noble gas configuration. But the ones that do not follow the octet rule, which ones are those? It's hydrogen, helium, lithium, beryllium, boron. Okay, these do not follow the octet rule. So keep that in mind. Next is the transition elements, the d block elements, the ones that have d block, the ones that have like starting from 3D. D orbitals, they do not follow the octet rule. And the ones that are post transitions, the ones because they also have the D, the post transitions also have the D orbitals. So that is why they also defy the octet rules. And then the F block elements also do not follow the octet rule. So its octet rule is not like it's a universal thing. It's not like that. Okay. Next is the elements that are metal in the D block and the P block. They can form the variable valence state with more than one type of positive charge. We discussed that already. Okay, so this was one piece. Next is we are talking about the nomenclature in this set of homework. So metals by default, group 1A and 2A and like aluminum, their names don't change. Their names remain the same. So metal is named as is, but the non-metals, their name ends in "ide." Okay, now those metals that form more than one type of positive charge, those ones, the ones that have lesser number of charges, lower number of charges, these are also called a lower oxidation state or a lower valence state. So their ending is going to be in us, O-U-S, like cuprous. Okay, but the ones where there is a larger oxidation state or larger number of charges, okay, larger, higher valence state, their ending is in ic, I-C. Okay, and that ic is like, for example, cupric. Okay, Roman numerals, or you can also name them by the Roman numerals. Now, what are the Roman numerals? Now here, you know, 1, we write it as I, 2 is 2 I's, 3 is 3 I's, 4 is, sorry, where did I write this? 4 is I and a V, 5 is a V, 6 is V and I, 7 is V with 2 I's, 8 is V with 3 I's, 9 is I and X, 10 is an X, 11 is X and 1, and 12 is X and with 2 I's. So this is the way we write these. This is how we write these Roman numerals. Now, here it is. When we can use both of the terminologies in naming the metals with more than one type of positive charge. So as we said, copper +1 state is copper cuprous, or you can also write it as copper Roman numeral 1. Copper in +2 state is cupric, and you can also write it as copper with parenthesis number 2 I's, that is number 2. Similarly, iron, ferrous and ferric. Ferrous lower oxidation state, ferric a higher oxidation state. So it's not like that +2 will give like an us. No, it's very specific to the element. Okay, so that element iron can have 2 positive states, +2 and +3. The lower one is +2, so the name ferrous. The higher one is +3, so the name ferric, and you can also write a name in Roman numeral as iron 2 and iron 3. Okay, sim, stannous, and stannic. Stannous is +2 and stannic is +4. So this is with respect to tin. Okay, so this is the nomenclature. Now, that's something, this is also written in the handout. You can look in the table 6.5, okay, in the nomenclature, and there's also in the worksheets. Okay, so we are going to discuss the polyatomic ions later, but let's look at these. Let's look at these homework questions now. Okay, so write the ionic formula. So when we write the ionic formula, now this is a homework, like this is just a homework video. So the full-fledged lecture you can look like with many examples, but we're just doing from the examples from some of the books, and you also can refer to the worksheet. Okay, anyway, so here we have magnesium with +1, with +2, and iron, fluorine with -1. So crisscross, this number comes here to the base, and this number comes to the base of magnesium. So then what does it become? This becomes Mg. For 1, we don't write, but for fluorine, you're going to write MgF2. This means that magnesium, technically, if you understand it this way, magnesium is +2 charges. So to cancel out those +2 charges, you would need 2 fluorines, each with -1 charge. You get that? So then it becomes a neutral atom, and this becomes, the name is magnesium fluoride. Okay, next is aluminum and sulfur, again crisscross. So this number is going to come here, and this number comes here. So what do you become? So what does this become? This becomes Mg, oh sorry, not Mg, aluminum, sorry. Aluminum is Al2S3. Okay, this is how you crisscross and write the formula of a metal and a non-metal. Okay, next is write the symbols and the formula. Now, potassium, you should know the potassium for symbol. Potassium is K, and sulfur is S. So when these two meet, what happens? So we should know a few things here. Potassium belongs to group 1A, and sulfur belongs to group 6A. Okay, that means potassium has how many valence electrons? 1 valence electron. Okay, and sulfur has got 6 valence electrons. That means with that valence electrons, potassium will form +1 charge, and sulfur is going to form -2 charge. Remember, sulfur is in group 6A, -2. So how do you write this now? So let's write this. So here you have potassium +1, and you have sulfur -2. So now crisscross, this number comes here, and this number comes here. So what do you form now? This, you form this as K2S. That is the formula of this compound. Okay, aluminum and iodine, same story. Write down the symbol for aluminum. Aluminum symbol is aluminum, Al. Iodine symbol is I. Okay, aluminum, write down the group numbers. Write down the valence electrons, and based on that, the charge. Okay, so aluminum belongs to 3A. Iodine belongs to group 7A, right? 3A, how many valence electrons? 3 valence electrons. So therefore, this is going to form +3 charge. And you have iodine. Iodine is 7 valence electrons. So it will acquire 1 valence electron. So iodine will have -1. It will acquire 1 electron, sorry, not valence electrons, but so it becomes, iodine becomes -1. 7A, remember, 7A is -1. So now write this down, aluminum +3 and iodine -1. Okay, and here you have aluminum here, and this is this. So here you have now Al(I3), aluminum iodide. Okay, so aluminum and iodine, when they combine together, they form aluminum iodide. Okay, next, write the names of these ones. So here you have magnesium. You should be able to recognize magnesium. You have to memorize them. That's the only choice. And this is phosphorus. Remember, phosphorus is just a non-metal by itself. So the metals, their name remains the same. So magnesium is MAGNESIUM. SiUm. But phosphorus, non-metals, remember non-metals, they end in, sorry, the non-metals, they end in ide, I-D-E, okay, ending. So that's the ending of that. So this becomes phosphide, sorry. Let's bring this here, phosphide, P-H-O-S-P-H-I-D-E, phosphide, okay? Here, this is calcium, C-A-L-C-I-U-M, chloride, C-H-L-O-R-I-D-E, chloride, okay? Calcium and chlorine becomes chloride, phosphorus becomes phosphide, simple, okay? Next is name the ions, iron with +2 state. So this becomes, you can write this down as iron, I-R-O-N, and parenthesis 2. And the other name is ferrous, F-E-R-R-O-U-S. Okay, the charge represents the charge here. This represents the, goes in the parenthesis. And that represents the positive charge, that represents the valence state. Okay, here or the oxidation state. Okay, that's copper +2. So this, you can write this down as copper, C-O-P-P-E-R, and 2. And then here this becomes cupric, C-U-P-R-I-C, cupric. Okay, now zinc does not belong to that group of more than one type of positive charges. Zinc will only make +2 charge. Okay, so this is just going to be zinc, just by itself. Don't put it in the in the parentheses. Okay, now comes the naming of tin 2-chloride. Now tin 2. Now remember that this 2 is coming from top of, let me write this down here. This 2 is coming from top of the tin. Okay, going to say properly. So this 2 comes from on top of. Okay, and then for 1 we don't write. So chlorine is 1. Similarly here, if there is no number here, and no number here, we will discuss this in a minute. Okay, same as the state here, these two, what's happening here. Okay, so look at here. So this is tin, so name. So this is tin 2-chloride. Tin 2-chloride, okay? So that's one piece. Next is iron. Now here, let's say you don't know whether iron is in +2 or +3. Let's say you don't know. So what will you do? In this case, oxygen is always going to be -2. Oxygen is always -2. Okay, so now you will have to move backwards from here. So here you have iron and you have oxygen. So if this is -2, obviously this looks like a neutral molecule, right? There's no charge. There is no other number. So that means iron will be +2. Okay, +2 and -2 cancel out. That is why you have FeO. Let me write this again. This is +2. And that's for iron. Iron +2. So that +2 and -2 cancel out. So what is the name then? The name is iron 2 oxide. All right, iron 2 oxide. And you can also call it ferrous, F-E-R-R-O-U-S, oxide. Because remember, ferric is +3. So this, or iron 2 oxide. Same is the case with oxygen. If oxygen is -2, same thing. What is the oxidation number or the oxidation or state of oxygen, sulfur, or in other words, the charge on sulfur? So sulfur, the charge is -2. So when the charge is -2, then what happens? So here we will have to it's just backtracking. So sulfur is -2. And since this is also a neutral molecule, so that means copper will also have +2. So +2 and -2 cancel out, and that's how you get CuS. But what is the name? The name is, let me write this in a different color, Cu. So this is copper, CuPP, ER, copper 2 sulfide. And what is the other name? The other name is cupric sulfide. All right. So that's how this is how the naming occurs. Next is the formula. Write the formula of cobalt 2 for white. Cobalt 3 means CO. This is easy. So this is 3. Fluoride. Fluoride is coming from where? Group 7A. And 7A forms -1 charge, all of them. So fluorine will have -1 charge. Okay. So now you're going to crisscross. So this number comes here and this number goes here. So what do you get here? You get COF3. Okay, that's the formula. Next is magnesium chloride. So magnesium formula Mg. Okay, chloride is Cl. Okay. Chloride is in group 7A. So the charge is -1. Magnesium is group 2A. Let me put this here, 7A. So this charge is +2. This charge is -1. So these are all in tables. Okay, so you can capture this information. So now we have magnesium. Okay, here we have magnesium +2 state and chlorine -1 state. All right, so now you crisscross. This number comes here and this number comes here. And so what do you get here? You get MgCl2. All right, MgCl2, magnesium chloride. Okay, now let's look at the next more. Copper 2 phosphide. Now remember that phosphide means it's just phosphorus by itself. And copper 1. Copper 1 is Cu and the charge is +1. Remember, phosphorus is in group 5A. The charge is -3. So that's something, you know, this is, I've already put this in the table that I showed you earlier. And secondly, you have to memorize. Okay. Now this thing crisscross, this number comes here and this number comes here. And so what do you get here now? You get Cu3, what's happening here? Cu3P. Okay, Cu3P. Now lead 4 oxide, that's interesting. Now lead 4 means Pb +4, lead metals. Oxygen is oxide. Group 6A, charge is -2, so -2. Now crisscross. Now you have to look at one very important thing, and that is the lowest whole number ratio. So here this becomes PB2O4, but you look at the lowest whole number ratio. Okay, so lowest, so 2 and 4 cancel out. So 2 and 4 cancel out. So what do you get now? You get PbO2. This is the right formula. All right. So this is a very important question. This type of questions are going to be on the test. So just make sure that you practice more of these. I'm just doing a few from the book, but I really want you to practice. And you do have the answers written on the in the book and in the solutions manual. So you can always refer to those. All right. Okay. We're going to look at the polyatomic ions in the next video. All right. Thank you. Bye-bye.